Alright guys, this is our last lesson for Unit 2. It's Lesson 8. We're going to continue our discussion about inverse functions here. We're going to do two things. We're going to talk about graphs, the graphs of inverse functions. We'll also talk about how to evaluate and solve inverse functions. So let's go ahead and start off here. I've given you a graph or a table here of the function f of x, an input and an output. So I'm going to go ahead and start by plotting those points. We have 0, 0. We have 1, 1. We have 2, 4. And we have 3, 9. And so that's my graph of f of x there. And so, you know, another way to write this instead of as a table would be like this, like f of 3 equals 9, right? Or f of 2 equals 4. Because 3 is the input, 9 is the output. 2 is the input, then 4 is the output. Well, when you're doing inverse functions, which is what we're working our way towards here, we know that the input and output get switched. So for instance, if f of 3 equals 9, then that means that f inverse of 9 would have to equal 3. So that means when I plug in 9, I get 3. Or f inverse of 4 would give me 2. Or in other words, 4, 2. So the x's and y's get switched. Now, as you see, the tables are identical. It's just that the x and y columns have been reversed because that's what inverses do. So now we're going to go ahead and we're going to graph this inverse function. All right, so let's start by graphing 0, 0, and then 1, 1, and then 4, 2, and then 9, 3. So observe that graph of the inverse. It looks like the same shape, it just looks like it's been reflected. Okay, so if you guys can imagine like a perfectly diagonal line here, it's like the red line got reflected through that diagonal line, and the result would be the blue line, right? And that's what inverses always look like. They look like a reflection through that black dotted line. Another way I like to describe it to my students is I like to say, imagine you have a piece of paper and you paint on this side of the paper, and then you fold it along this black dotted line before it dries. When you're all done, the paint would have copied the image over here like that. It would have smeared to the other side and it would have looked like that. That's what we're talking about. That's what inverse functions look like. So there's our conclusion here on this slide. The graph of f inverse is a reflection of the graph of f, and the line of reflection is that black diagonal line you see there. Now that's a straight line, right? We talked about linear functions in Unit 1. You'll notice that the y-intercept is 0, and you can't tell from the graph here, but the slope is 1. So if you have a linear function with a y-intercept of 0 and a slope of 1, and you simplify that, you get y equals x. So that's the equation of the black diagonal line, and that's the line that all inverse functions are reflected through so that they match their original. Another thing that we've noticed is that if AB is a point on a function, then BA will be a point on its inverse because the x's and y's get switched. All right. Now I want to talk to you guys a little bit about domain and range. Back in Unit 1, I think it was maybe it was Unit 2 actually, I forget. But it was a past lesson. We talked about domain and range. Domain is all the possible values of x Range is all the possible values of y. So let's go ahead and start with the red line, which I'm going to call f of x. You might want to add that on your notes as well. The x value that's farthest to the left is here, and that would be x equals 0. And then it's a solid dot, so I can put an equal sign there. And then after that, it just looks like it keeps going off to the right forever, so we can put infinity over here. Now for the range, the lowest point is right here, which is 3. And once again, the highest point just keeps going up, so we'll put that there. Well, let's take a look at the inverse. As you guys could tell, I mean, once again, we know that that's the inverse because it looks like it's been reflected across this black dotted line, doesn't it? So that's an inverse function that we have graphed there. So let's label that as f inverse. Well, let's do the domain and range of this inverse function. All right. Domain are all the possible values of x. So we start by putting the x value that's farthest to the left. That would be here. So that's 3. But after that, it just keeps going to the right forever. Let's do the range. Range is the lowest point, which once again, it's that same spot there. So but this time the y value is 0. After that, it just kind of keeps getting higher and higher. So we'll go ahead and put infinity there. Now, I want you guys to compare the domain and range of the function f with its inverse. Well, they're the same. It's just that they're switched. The range of f is the domain of f inverse. And the domain of f is the range of f inverse. And that makes sense because, once again, what is an inverse? It's just where you switch the x's and y's. And what is domain and range? Domain and range are just all the possible values of x and y. So switching an inverse basically just reverses the domain and range around. Okay, so we have that fun little fact now, which I've got summarized here, but I think there might be an error on this slide unless I fixed it last year. I remember this last year I didn't have it right. So let's read it carefully. So how does the domain and range of a function compare to the domain and range of its inverse? The domain in f is the range of f inverse and vice versa. That is, if f of x has a domain of a to b and a range of c to d, then f inverse has a domain of c to d and a range of a to b. Okay, I must have fixed the error because that all looks correct to me. All right, so we're good. All right, moving on to example 1. So the first thing we want to do today is we want to kind of explore and work with this idea of what do inverse functions and their graphs look like. Okay, and also we'll look at the domain and range a little bit. So here we go. The graph of f is given at the right, so the red line over there represents f. The first thing I want to do is I want to state the domain and range of that line. So let's do that. Okay, so all the possible values of x. It looks like it goes from x equals 1 to x equals 7. And those are closed dots, so we'll put some equal signs there. And as for the range, the lowest y value on the graph is -3. And the highest y value seems to be 2. And once again, we're going to put equal signs there. So that's it for that. Let's go ahead and sketch f inverse. Now this is where you guys want to pay attention closely, okay? So before I can actually do this sketch here, what I need to do is I need to pick a couple of points on the line that I have. Now I've already got 2. I've got this point here, and I've also got a point over here. But let's pick a few other ones, like right here. Let's do another one, and let's do this one. Pick as many as you can. Those are the only 2 that I can really find other than the endpoints. But you want to have a few points, okay? Not just the endpoints. You want to have a couple. I don't really want to pick any other ones because none of the other ones are crossing at nice places. So, and what I'm going to do is I'm going to label these really quick with their coordinates. Okay. So the coordinates of this point on the left is 1, -3. And then the point on the next point over is 2, -1. Next we have 5, 1. And lastly 7, 2. All right, so in order to sketch the graph of f inverse, the first thing I'm going to ask you guys to do is pick a few points on F and label them. The next thing we're going to do is we're going to plot the inverse points. So we're going to plot the inverse points. So for instance, let's consider that point right there. Well, the inverse point of that would be just reversing the numbers. So that would be the point -3, 1. So left 3, up 1 would be like right here. See that? It's the same point, it's just that the x and y have been switched. So we're going to plot that. Let's do the next one. The next point is 2, -1. If I reverse that, I get -1, 2. Next one is 5, 1. Let's reverse that. 1, 5. The next one is 7, 2. Let's reverse that. You're going to get 2, 7. And then you just go ahead and connect your dots. And when you're all done, it should look like a reflection in this diagonal dotted line here. If you want to put it on there, you can. And it does. So we've done a good job. It's completely symmetrical around that dotted line. So there's our sketch. So we're done with that one. All right, now let's go ahead and state the domain and range of F inverse. Now you could do this the long way or the fast way. I'm going to do it the fast way. The long way, as you guys know, would be to list all the possible values of x and y by looking at the far left, far right points. But we learned something on the last slide. We learned that the inverse, well, the domain of the inverse is the range of the original. So what do I mean by that? What I mean is that if this is the range of f, then for the inverse, that will be its domain. Notice I changed it from y to x and I put it in a domain. Contrary-wise, if this is the domain of f, then that will be the range of the inverse. Okay? So that's the easier way. Just copy your answer from above, just reverse them. But you could still do it the old school way if you prefer. It's up to you. All right? So that's example 1A. Let's do another one here. And the reason why I'm doing another example is just for more practice, but also every one of these something a little different happens. On this one, the inverse function and the regular function are going to actually overlap each other a little bit. So let's start by putting our domain and range. So as I look at this graph here, I see that the point that's farthest to the left has an x value of -2. And it never stops going to the right, so that would be infinity. As for the range, the lowest point on this graph doesn't exist because it just keeps going down. So there is no lowest point, so we're going to say that the lowest point is -infinity. The highest point, otherwise, though, is this dot up here in the top left, which has got a y value of 3. So there's my domain and range. Now let's sketch the graph of F inverse. Now, you don't need to do too many points, but you need enough to be able to copy the graph, right? So we'll go with this one here, the endpoint, obviously. But let's pick a few others. We don't need a lot. Let's just kind of go for like maybe 4 or 5. That'll be good enough. And let's put the coordinates on there. So that's -2, 3. 0, 1, 2, -1, and 5, -4. Okay, so now I want to sketch the inverse by plotting the inverse points. So the inverse of -2, 3 will be 3, -2. The inverse of 0, 1 will be 1, 0. The inverse of 2, -1 will be -1, 2. And then finally, the inverse of 5, 4 will be negative 4, 5. So what's kind of irritating about this one is that the inverse overlaps with the red one, so it's kind of confusing. But if you just follow the process, it works. They're still a reflection of each other in that dotted line there. Okay. Now let's go ahead and do the domain and range once again. If this is the range of f, then that will be the domain for its inverse. I'm going to erase that equal sign. It can't equal infinity. All right. And the same thing applies to the range here. So the next one will be negative 2 and infinity, because the domain of f is the range of its inverse. Okay? Let's do another one. The reason I included this one was because it's hard to sketch. This one actually turns out to be a little bit difficult to draw. So let's go ahead and give it a try. Sometimes these inverses can be tricky. All right. So let's do the domain first. I see a closed dot here and an open dot here. So that means we're going to have some endpoints here. It looks like the point that's farthest to the left is negative 2. And it's a closed dot, so we put an equal sign. And the point that's farthest to the right is a positive 2, but it's an open dot, so we won't put an equal sign. And as for the range, regarding the y values, the lowest point is the one on the very bottom there, which is negative 8. And it can have an equal sign because it's a closed dot. And then the one that's highest would be positive 8, but it's an open dot, so no equal sign. So there's our domain and range. Now we're going to graph the inverse, so we're going to follow the same process as always. We're going to label these. I should use a different color, actually. I don't want to confuse you guys. I've been using blue for the inverse. So since we're working on the regular function right now, I'm going to stick with red. Okay, so now we're going to go ahead and flip those numbers around and graph their inverses. So 2, 8 becomes 8, 2. 2, 8 becomes 8, 2. 1, 1, if you reverse it, it stays the same. Same thing with 0, 0. Same thing with negative 1, negative 1. And then finally, the last one here, negative 2, negative 8 becomes negative 8, negative 2. Now, I mean, if you don't connect them perfectly, it's okay. But I would encourage you to try to connect the dots. You know, pause the video here and see if you can connect the dots the way they're supposed to be connected, and then see how to do it when you unpause it. Here's how I would do it. It would go like this. There you go. Once again, it should look like a symmetrical reflection through the black dotted diagonal line. Well, I drew it blue, but oh well. There you go. All right, as for the domain and range, once again, the range of f is the domain of its inverse. And the domain of f is the range of its inverse. All right. All right, guys, so here's some for you. I would like you to do the same things that I just did. I want you to, for each one of these, I would like you guys to state the domain and range of f. And then I would like you to sketch the inverse. And when you're done sketching the inverse, I would like you to state the domain and range of the inverse. And you're going to do that for all three of these. Okay? I'll go ahead and continue writing this stuff, but if you guys want, you can go ahead and pause the video and start working on it. And when you unpause it, I'll have the answer up for you. Okay, there you guys go. I think most of it's pretty self-explanatory. I'll let you guys check your answers. But one thing I would point out is that on the last one here, the graph actually has an asymptote here. Let me use a different color here. So this graph here is trying to get closer and closer to that line, but it doesn't get there. Now whenever I graphed it, I just kind of pretended there was a point at -3, 0. So when I flipped it, I just put a point at 0, -3. But really it doesn't touch that point. What's happening is this one's getting closer and closer to a vertical asymptote. And that's because it got flipped and reversed. And that's why on our domains and ranges here, it doesn't actually equal 0. It just gets closer and closer to 0. So there's that one. All right. Next. So now we're going to talk about evaluating inverse functions and solving inverse functions. So let's go ahead and work on this a little bit. So as you guys know, as you know, if f of x equals y, then f inverse of y equals x, right? So we can kind of use that inverse relationship there to kind of figure out the solutions to these. So some of these questions are review questions, like this one, for instance. That's a review question. F of -3. Well, since this is f, that means the number in parentheses there, the -3, is an x. And the output is a y. So on my graph here of f of x, I'm going to look for where x equals -3. And then I'm going to ask myself, what's the y value? And the answer is -3. Now let's take a look at part B there. Now this is not the graph of f though. We're talking about f inverse. Now when you're talking about f inverse, the number in parentheses is actually going to be the y value of the f graph, and the output is the x value of the f graph. So now what I want to do is on this graph of f here, I want to find where does y equal -1. And then I'm going to ask myself, what's the x value that goes with that? And the answer is -2. So both of those are examples of evaluating because I'm giving you the input and asking for the output. All right. Now let's look at the reverse. For the next one here, we have f again. So we're back to the regular f graph. So the one in parentheses is the x. The one outside that it's equal to is the y. So on this one, I know that the y value is 0, but I'm wondering what is the x value. So what I want to do then is on my graph, I want to find where does y equal 0. And that would be like right about here. So it looks like it's just before the -1. I think we could just round it. Let's cheat a little bit and just say it is -1. Why not? So there we go. Now for the next one, f inverse. When you're looking at f inverse, the number in parentheses is the y, and the other one is the x. So in this case, I don't know what the y is, but I do know what the x is. So now I want to find where does x equal 3, and I want to ask myself what's the y value that goes with it, and the answer is 2. So basically, what I'm going to advise you guys to do for this problem, as well as the one that comes after it, is start by writing this. It's really helpful so that you can use that as kind of like a key to go back to figure out what you need to find and what you need to be looking for. All right, so using that same principle, let's go ahead and do number 2. Same thing, it's just that right now we're going to be working with a table instead of a graph. So g of x equals y. That means that g inverse of y equals x. So once again, start the same way by writing this and this. That's going to serve as our key for doing these problems. So for g, that's this one. The number in parentheses is an x, and the output's a y. So I know my x is 3. So I want to look for where does x equal 3 in the table. That would be right here. And the y value that goes with that is 1, so that would be my answer. Now for part 2 here, or part B, now we're working with g inverse. So we're looking at this one now, which means that the number in parentheses is actually a y value, which means the answer I want is an x. So now I want to look for where does y equal 2. So I'm going to look in the y column for where y equals 2, and I'm going to look at the x value that goes with it, which is 1. So that would be the answer. Let's do another one here. So again, I'm looking at the g, and when you're looking at g, this is the x and this is the y. So I want to find where does y equal 3, and the x value that goes with that is 0. Last one. This is g inverse, and when you're doing g inverse, this number is sorry, that's incorrect. This number is the x, and this number is the y. So I want to look for where does x equal 1, and the answer that goes with that is 2. Notice that I just asked the same question twice, just in a different way. All right, so there you guys go. That is how you solve and evaluate inverse functions using graphs and tables. So let's go ahead and let you guys try some. So go ahead and pause the video here, and when you unpause it, you will see the solutions. Okay, there you guys go. Those are your solutions. And I think that might end our lesson. Let's see. No, it doesn't end our lesson. We got a little bit more. Sorry. Didn't mean to get you all excited there. All right. You guys remember the vertical line test? That was something we used to determine if something was a function or not. So like, for instance, since that only hits it once, yes, that would be a function. But since this hits it twice, this would not be a function, because every input should have only one output, okay? But beyond that, what else? What do you guys notice about this graph that I've drawn? These two different lines. Well, in case you haven't noticed, those two graphs are inverses of each other, okay? Now, not every function can have an inverse. And here's why. Because even though this graph over here on the left is a function, because it passes the vertical line test, the problem is that whenever I draw its inverse does not pass the vertical line test. It fails the vertical line test, which means that the inverse doesn't technically exist. Okay? It doesn't mean you can't draw the picture. You can. It's just that that picture doesn't represent what we have called a function. A function is where every input has one output. And for this graph that's in red here, an input of 2 has 2 different outputs, here and here. So even though you can draw the picture, technically we would say that it doesn't have an inverse. Now, instead of actually going through the trouble, though, of drawing the inverse, there's a way you can know if a function has an inverse or not, and it's what we call the horizontal line test. Okay? So here's how it works. If you draw a horizontal line and it touches twice, even though that may be a function because it passes the vertical line test, it only touches once, but if it fails a horizontal line test, that means when you flip it over, it will fail the vertical line test, and so there would not be an inverse. And so what we say then is that if it passes the vertical line test, cool, it's a function. But if it doesn't pass the horizontal line test, then that function does not have an inverse. Okay? So we call that the horizontal line test. If you draw a horizontal line and only hits it once, the inverse exists. If you draw a horizontal line and it hits it twice, the inverse does not exist. So, example 3 here asks us to determine, do these functions have an inverse? And by the way, both of these are functions. So for instance, if I draw a vertical line, it hits it once. No matter where I draw a line, it'll always hit it once. Same thing over here. So both of these graphs are functions. The question, though, is do these functions have an inverse? And the way we answer that is with the horizontal line test. So if I draw a horizontal line, it touches it much more than one time. And therefore the answer is no, there is no inverse for this particular function. Whereas for this one over here, if I draw a horizontal line, it only hits it once. So therefore this one would have an inverse. In fact, we could probably draw the inverse. It would probably look something like that. And so, as you can see, that inverse function passes the vertical line test, so that is a function in itself, since it passes the vertical line test. And the reason the inverse passes the vertical line test is because the original one passed the horizontal line test. All right? So, vertical line tells you if something's a function or not. Horizontal line tells you if it has an inverse function or not. Okay? So here is a student practice for you guys. I'd like you guys to go ahead and try numbers 1 through 3. The reason, now I'm kind of throwing you guys for a loop here on numbers 2 and 3, and that's on purpose because your homework will be like that. So I want you guys to get a chance to kind of see what that's going to look like. Number 1, I've already given you the graph, so that's just like the one I did. Number 2, I've given you the equation, so go graph it on Desmos.com. Go to Desmos.com, Desmos.com. Go to Desmos.com and graph this function, and then once you look at the graph, then you can answer it. For number 3, you can graph these points, and you can use the points, the graph of your points there to determine if it works or not. Okay, so go ahead and pause the video here and give those things a try, and when you unpause it, I will go over the answers with you. Okay, so for number 1, it passes the horizontal line test, so this one is a yes. This graph would have an inverse. For the next one here, I told you guys to go check out Desmos.com. Okay, if you're not familiar with Desmos, I would encourage you guys to check it out. It's a pretty cool little website. It works pretty well. So, so you click on Graphing Calculator. Go ahead and type in your function there. My function was x cubed minus 2x squared. So we're going to do x to the power of 3. To get the power, you push this the little symbol that looks like this on your keyboard. Oops, that did not go according to plan. So power of 3, And I think it was plus 2x squared, was it? No, minus 2x squared. So there's the graph. Now, as you guys can see, that will not pass the horizontal line test. And so the answer to number 2 would be no. All right. As for the last one, we just need to graph the points in the table, and we can kind of tell if that one is a function or not. Okay, and as you guys can see here, that's the graph of those points, and I just connected the dots. And as you can see, that would not pass the horizontal line test, and so that there is another no. So these two were no's, and this one was a yes. And remember, we're answering a different question than the last time we did a line test, right? We're not deciding are these functions. All of these things are functions here. What we're answering is do these functions have an inverse? And the way we do that is with the horizontal line test. So that probably concludes our lesson for today. And so that's our last lesson for Unit 2. So next time we'll be just working on a study guide, getting ready for our next test. See you guys then.